Hello. We are moving on with our chapter 9 lessons today. We are starting up 9.2, which is kind of where things get a little bit more complicated, where we start to have operations. Operations meaning like plus, minus, multiply, divide, those types of operations that go into probability. And the main idea with these operations is this idea between intersection and union, which is also this idea of the word and or. So you can have a probability of this, or you can have a probability of this and this. Both of these things need to happen is the and word versus like any one of these things could happen, could be the or word. So that's the kind of general idea of what we're going to be playing around with in this unit is and versus or and what that means for probability. Really quickly, I'm just grabbing a spare piece of paper, which just happens to be at the back of your notes. We'll write it up here. Just think real quickly about probabilities. Probabilities are always going to be less than 1. We talked about that as one of our rules of probability last unit, which means that since they represent a percentage of a likelihood of something happening, they're always going to be less than 1. If your probability is 1, that means 100% of the time this will happen. I will always be with a probability of 1, Megan Connor, right? That will always just be. So with that, since we have probabilities that are less than 1, that means that we have decimals or fractions representing these probabilities. And I just want to remind you that when we have something like a half times a half or a half times a fourth, when you're multiplying numbers that are less than 1, what happens is those numbers get smaller, right? A half times a half is a fourth, 1 over 4. And then a half times a fourth is 1 over 8. So this would be like 0.5, right? 0.5 would be one of those, and then it becomes 0.25, right? So we started with a number that was larger, 0.5, and we got to a number that was smaller because we multiplied by something that was less than 1. So when you're multiplying fractions together, they get smaller. Versus when you're adding fractions together, this would be 3/4, they get bigger. So the operation of adding probabilities gets larger versus the operation of multiplying probabilities gets smaller. So this idea of and versus or, multiplication gets smaller, addition gets bigger, is something to keep in mind, those relationships, as we're moving forward with these notes. Okay. So we have the intersection versus the union, and we talked about this the last time we were in class. In order to be able to do our 9.1 check for understanding, it already assumed that you understood what these were, which maybe you did from your previous, like from class, like Math 10, or maybe you don't remember it, and that's fine. So the intersection, I always remember because in feels like it starts with an N. And so the intersection is the symbol that kind of looks like a lowercase n. That's like the weird connections that I made when I was your age, when I was learning what these were. But that this bridge guy, it looks kind of like a weird lowercase n, and that's how I remember with intersection. So this is what the intersection is. It's this idea of the word and. It has to be this and this. Both of these things need to come together in order for us to then be able to move forward. And so it's the bridge between the two. So it's a bridge between those two sets, a bridge between those two events. And it's maybe what they share. Okay, so it's this idea of like, what do they share? Or that they are sharing something, they have to be together. If I want to know if I've got like so many sweaters in my closet and I have so many red articles of clothing in my closet, the probability of me picking just a sweater is one probability, but the probability of me picking a red sweater starts to get more specific. It has to be a sweater and it is red. So this is idea of intersection with the and is that it's getting more and more specific, which means that the probability of you picking one out gets smaller and smaller because it's harder to get that randomly. The visual representation of this if this is B and this is C, if we're talking about a Venn diagram, the visual representation of what they share, their overlapping piece, is the overlapping part of the Venn diagram. This is the intersection. Going back to what I was saying earlier about the fact that like the probability of me picking a sweater and the fact that it is red are these extra layers of requirements in order to satisfy that situation. This and this needs to happen in order for it to work, which means I'm getting more and more specific, which means the probability of it gets smaller and smaller. And multiplying probabilities together will always result in smaller numbers. So if you just kind of think about it logically, the fact that we're using the word and is making it so specific that the probability gets smaller, then that means that the probability of B and C, in other words, the intersection of B and C, is the probability of B times the probability of C. So if you can take any probability that you're looking at and turn it into this idea of and, then you'll know that it's a multiplication operation that needs to happen. So that's kind of the main takeaway from all of this is this is the operation that goes with intersection. Versus union. Union's a little bit easier to remember because the symbol is a U. It's this idea of or. This could happen or this could happen, right? If I have so many pants in my closet and so many sweaters in my closet, what's the probability of me picking a sweater or a pant from the laundry pile, right? You're starting to like build up the number of options available to me. I could pick out any pant or I could pick out any sweater and I would satisfy the conditions, which means that's a pretty large probability. So this word of or is a probability that gets larger and larger and larger the more things you add on to it. This or this or this would make your probabilities larger. And the way that we make probabilities larger is by adding them. So if you're saying, well, I could pick up a sweater or I could pick up a pair of pants and I would still be satisfying this condition, it's this idea of a bowl is kind of how I think about it. And the visual representation here, I think of like a bridge between the two. Versus this as a bowl, that I can put anything into the union. I could either pick a sweater or I could pick pants. Those probabilities just kind of get like mixed into this bowl of options that are okay. So it's this idea of everything together. So in terms of a Venn diagram representing it, B or C is anything that is in B or C. I want you to be very careful though, because notice that you have a section of this Venn diagram that's accounted for twice, okay? So how you calculate for the union is you're like, okay, well, it's the probability of this or the probability of this. And so your probabilities are getting larger, and so you're adding them together. The probability of B or C is the probability of B plus the probability of C. Now, the careful thing, the thing you have to be really worried about here is if they are not independent. In other words, if there's some sort of overlap between the two worlds. Remember from our last note that I was talking about, like, what's the probability of getting more than a 5 when you rolled a die, or what's the probability of getting more than a 5 from pulling numbers? It was numbers 0 through 9. What's the probability of pulling more than a 5? And what's the probability of getting an odd number? Well, there was like 7 and 9 that were both more than 5 and also an odd number. So there's overlap there, which means that if you're counting for all of B and all of C, you've added in this section right here 2 times. So for instance, we would have added in the probability of 7 twice and the probability of 9 twice in that last example that we worked with in our last notes. So since you're accounting for it more than once, exactly 2 times, you're going to subtract out one of the options that you added in, one of the probabilities that you added in. Which means I need to subtract out the intersection of these two, the shared piece, the overlap of these two sets. And so that's minus the probability of B intersection C. And so that's the formula for OR. Is you add them together. If they are not independent, then you need to subtract out their intersection. You can always subtract out their intersection, and if they are independent, if there's no overlap in the circles of that Venn diagram, then that means that the intersection of them is 0, and so you're just subtracting out 0. So that's totally fine. Okay,